Hey guys, we're going to go over this real quick, then you'll be able to do your test. It's very similar to this, so please take notes and turn in your thumb. All right. When you guys do that, I want you to look. Remember, it goes opposite, same. So this is going to be right 3, down 1. If I go right 3 and down 1, okay, that's my first point. Now, with transformations, what I want you guys to do is to remember how we would go, like the regular graph of x squared goes 0, 0, 1, 1, 2, 4. Is 1 squared is 1, 2 squared is 4, and same thing on the other side, 1, 1, 2, 4, and then that's all you're going to be doing for transformations. Okay, so same idea over here. This one moves right 1 up 4, the right one up 4, and then again it's 0, 0, 1, 1, 2, 4. Now the only thing you got to remember is if it's a minus, we go this way. So 1, 1, 2, 4, 2, 4, and then we can go ahead and draw that. Okay, so try to draw it as carefully as you can. That's how we're going to do transformations. All right, our next question is standard form. Now, when you guys are doing standard form, so we're going to find the axis of symmetry, the vertex, the x-intercept, the y-intercept, and then we'll just go ahead and state the domain and range. Okay? Okay, the two things I need to remember for standard form. The axis of symmetry comes from negative b over 2a. All right? You guys would like to write that somewhere on the board and have that for the test. Okay, so check it out. Negative, right here, b is negative over 2, and right here, a is 1. So negative 8 over 2 is 4. You guys, that's my axis of symmetry. Okay, so you're going to draw right down at 4 for axis of symmetry. Now, the way I get the vertex, we talked about this, you've got to plug that in to this equation right here. It's okay if you guys want to use calculators, but we're going to go r squared times 12. Okay, well, 4 squared is 16 minus 32 plus 12, which gives me negative 4. The way I write it, or negative 4. That's my vertex. Okay? Now, the next thing I need you to remember, standard form, is that, sorry, let me lock this, is that the x-intercepts come from back. All right? If I set this equal to 0, x squared minus 8x plus 12 equals 0, I factor it, I end up getting, remember you take the opposites for my x-intercepts, 6 and 2. I can write that as 6, 0 and 2, 0. Okay? And then for my y-intercept, I just plug in 0 to here. 0 squared minus 8 times 0, 12, gives me a y-intercept of 12. Now, if it goes so far off the graph, all right, let me just draw my graph real quick here. And I end up getting that my domain is negative infinity to infinity, and my range is a bracket negative 4 to infinity. Okay? Cool. So that's all the stuff that I'm... So, we're going to do the same stuff over here. Axis, vertex, x-intercepts, y-intercepts, domain, range. Okay? All right. Axis of symmetry, again, is negative over 2a is 4. Okay, so I'll go ahead and draw my axis of symmetry right here. And then when I go to plug, I go to make it negative 4 squared plus 8 times 4 minus 15. Negative plus 32 minus 15. It's going to be like 1, I think. Okay, so there's my vertex. All right, now you know how when we are getting our x-intercepts, we have to factor them. So let me come back to factor that. You guys, if you ever have a when you're factoring, I want you to go ahead and take that negative out, change the signs of everything. Then I say 5 and 3 both. All right. So I get x equals 5 and x equals 3. As x-intercepts, I could write those as 5, 0, 3, 0. Then again, my y-intercept is plugging in 0 right here. Negative 0 squared plus 8 times 0 minus 15. My y-intercept is negative 15. Again, that goes off the graph. So that's okay. You don't have to use it. All right. My domain is going to be negative infinity to infinity. My range will be negative infinity to 1 bracket. Okay? Cool. So that's how we go ahead and do standard. All right. My next one is vertex form. Now, we like these. These are a little bit easier to find axis of symmetry, the vertex. X-intercept is a little tricky, and then y-intercept. Anyways, it's very similar to transformations, you guys, where it's opposite name. My vertex is positive 4, axis of symmetry at 1. Because it's just the x-coordinate of the vertex. All right, now, this one, we're not factoring. To find the x-intercepts, what I'm going to take, put a 0, and I'm going to solve. Well, the way I do that is I add 4. I divide by a negative. That gives me negative 4. What I want you guys to know, we're going to automatically put that there are no x-intercepts. Okay? In terms of y-intercept, a little bit more. Remember order of operations, you guys, square it first. Negative 1 squared is 1. And then I put the negative on there. And so negative 1 and negative 5. And I mirror that part over. There's no x-intercepts, so I've got everything. Okay? Okay, let's take a look at axis, vertex, x-intercepts, y-intercept. Okay. The axis of symmetry is opposite. Then the vertex is same, so opposite same. Axis positive with the vertex at the point 1. Okay, I need to set this equal to 0 and solve it. So I'm going to subtract 2. I'm going to divide by negative 2. And I'm going to square root both sides. Okay? So I get x minus 1 is plus or minus 1. All right? Whenever you square both sides, you want to do plus or minus. When I add 1 over, I need to do the positive. Positive 1 plus 1 is 2. And then I need to do the negative. Negative 1 plus 1 is 0. So those are my x-intercepts. So I can write them as 2, 0, and 0, 0. And then the last part, you guys, is my y-intercept where I order of operations tells me to do that first. 0 minus 1 is negative 1 squared is 1. Negative 2 times 1 plus 2 is 0. Whenever it has a 0, 0, that actually is the x and the y-intercept. Okay? I have one more type of graphing to show you. That's graphing using factored form. I kind of like this one. I think it's like maybe the easiest. Let's see. The big thing you want to remember is with this one, we are actually starting with x-intercepts, okay? If I come over here, my x-intercepts are negative 5, positive 3. I can write that as negative 5, 0, 3, 0. Okay? That's my solution. Now, what I do is I believe exactly halfway to say means that my vertex, all right, so negative, that's 4, that's negative. That's negative. So, I don't mean to make it go off the graph so much, but like down here somewhere. All right, my y-intercept is just like, so if I do, I get 5, 50 is 15. Okay. All right, cool. One more factored form, and we'll look at some factoring examples. Okay, again, starting with the x-intercepts at 4 and 2. Cool, cool. All right, halfway in between those is an axis of symmetry at 3. And then the vertex, I need to plug in 3. Now I use the negative 2, I leave that out there. Score 3 minus 2. It's negative 2, negative 1 times 1, which gives me 2. So the 0.32 is my vertex. Then for my y-intercepts, I hey, you guys, so this is negative times negative 4 times negative. 3 negatives make a negative 16. Like way down there. Okay? All right, so try to remember all the different things for graphing and the different forms. Pretty much the rest of the test, you guys, is fact. Now, on fact, just so if it were to say solve, if it were to say that, I would write, if it says solve, if it just says factor, okay? All right, so let's go through and do these. Multiplies to make 28 and adds to make 11 is 7 and 4. Multiplies to make 4 and subtracts. This one is plus 2 minus 1. This one is minus plus 7. and that's plus 7 plus 1. So we call that just like regular trinomial factor. Okay? My next set of questions, squares. Um, 5x, 8, 1 plus 1 minus. Okay? This goes to, now look, there's some extra letters in x squared is xx. A squared is 16 squared is 1 plus 1 minus. All right, and then I have some cube pattern. Okay? Here's the pattern. You take the circumference, you do that, you join them, and then you go same, opposite, always positive. Okay? So my cubes here would be 2x and 1. Square that would be 4x squared. Square that would be 1. Join them would be 2x. And it's same, opposite, always positive. Okay? All right, so that's plus x. It looks like it's in a backwards order with the number first and the letter second. Don't try to like turn that around or anything. So that'll be 15 x, that'll be 4x. Same, that's going to be 4x and 3. That squared will be 16x squared. That squared will be 9. Together, that's going to be 12x. Same, opposite. Okay? 216 is 6. So that's 30. 1 squared is 1. Join them together. And then it's opposite. X squared. The last one is 36. Join together is 6x. Same. Okay? And then the last little part is going to be not doing like not like factoring or we move the term out and 48 out. We take half of the middle, square it, and if I put plus 1, I have to put minus 1 to balance it out. So my answer goes, well, first you say, what is this factor to? And that factors to x minus 1 squared. And then negative 41, negative 48 minus 1 is negative. Okay? Oh, I'll show you the rest of these real quick. Bring the 45 out here. Half of 14 is 7. Squared is 49. That's x plus 7 squared minus 4. Okay, let's see this one. Move the 16 out. Half of 5 is 25. I added 25. That factors to m minus 5 squared. And 16 minus 25 is negative 9. Okay? Half of 6 is 3. Squared is 9. If I add 9, I have to subtract 9. So I get a minus 3 squared. And 5 minus 9 is negative 4. 8n minus n minus half of 8 is 4. Squared is 6 minus that equals n minus 4 squared. 5. Half of 2 is 1. Squared is 1. Plus 1 minus 1. This gives me n minus 1 squared minus 1. Okay? Half of 4 is 2. Squared is 4. Plus 4 minus 4. Got x squared minus 5. All right, and last one here. Half of 8 is 4. Squared is 16. Plus 16 minus 16. So this is b plus 4 squared minus 4. Okay, so guys, go ahead and please turn your packets in. Any extra late work, please turn in. Our test right now. No notes, no talking. Thank you.